Hey, I just wanted to talk to you today about how you can build an AI agent using the SMOL framework from Hugging Face to solve various CTF challenges that might be out there in the cybersecurity space. All right, let's get going. The course material here comes from a training I gave at the Apres Cyber Slope Summit up in Park City, Utah, called AI-gent Smith, and talked about how to build AI agents for cybersecurity purposes, and this is really just one small portion of that training. So if you're interested in that type of material, check out the Apres Cyber Slope Summit next year in 2026. Also, it's hosted in Park City, Utah, which is one of the biggest ski resorts in the USA, and typically has pretty awesome snow. Okay, so SMOLAgents. What is it? Small and simple library for AI agents. This was released by Hugging Face, a really small code base, a really good support for any of the models that are on Hugging Face, and has a killer feature being code agents that we'll talk about more in a minute. If you don't know what Hugging Face is, you can browse over to huggingface.co and you can register yourself an account. When you log in, you'll see something similar to this. This is kind of an ecosystem where you can use any models that are available in the ecosystem. So for example, if you wanted to generate an image, Black Forest Labs, the Flux.1-dev model is pretty great these days. So you could use this interface to go ahead and do that, or you could also access this stuff via the APIs. In addition, there's datasets if you want to tune or train AI models. And then there's this pretty cool ecosystem called Spaces. And what Spaces are is they're little mini web apps inside of Hugging Face, which allow you to, test out somebody's idea, usually relating to AI. So like, for example, this city app, it's going to build a 3D city for us. So we can go in here, we kind of tweak some of the settings, and when we're happy with it, we could click submit. And once we do that, it was going to generate, a 3D city for us. So really, these are just for creative folks that are trying to push AI to the limits and come up with new ideas and then share them with other people. When things get popular enough in these ecosystems, a lot of times companies are rolling them into their production tools or their SaaS products. This is really a place to see the most bleeding edge AI technologies out there and a way to easily convey them to your friends and family. All right, enough on Hugging Face. Let's get back to the agents ecosystem. So one thing that's pretty cool about the SMOLAgents is under the hood, you don't have to use Hugging Face. You can use this library called LiteLLM. It has a direct integration with it. And what that does is it's basically a facade that allows you to interface with many different LLM providers out there. So there's over 100 LLM providers supported in this open source framework, this LiteLLM. And so, let's say you wanted to use Claude's model instead of OpenAI's model, or any other provider out there like a Google Gemini. LiteLLM is going to translate the API calls from the OpenAI format to whatever the format is required for that other provider, and then translate them back and forth. So really, don't feel like you're stuck on the Hugging Face ecosystem here. If you want to use a different LLM provider, you can do so via LiteLLM if they're supported, which with over 100 LLM services, whatever you want to use is probably supported this way. Now, I've tested this quite a bit and it works pretty well. Now, one of the killer features, in my opinion, about SMOLAgents is the fact that they have a much better framework for doing tool use. And essentially, when you go to call a tool or a function call on most LLMs, they're going to return you back a JSON blob. And then you're going to be responsible inside your code base for parsing that JSON blob and then parsing the data that's relevant to the right functions inside your Python code, and then taking the actions and then returning the results from those actions back to the LLM so it continue to make further decisions. So this process is greatly simplified in the SMOLAgents framework. In the SMOLAgents framework, instead of the LLM returning a JSON object, it will actually return native Python code when it makes sense. And so really all your code needs to do is eval that Python code and then return the results from the eval Python code. There's some stats on the webpage if you want to check them out, but this is much more efficient than the previous JSON model. Albeit, there are some risks with just taking whatever code the LLM is providing back to you and executing it. And so there's some guardrails placed in the framework to help prevent malicious actions from occurring. Based on my testing, I haven't had anything negative occur yet. But you could get weird results from the LLM always. And in addition, I run most of my environments inside of Docker containers. So, even if something weird were to occur, it's relatively easy for me to get back to a known good state. So that'd be my, recommendation to you as well. You probably don't want to run these type of agents on bare metal hardware. You probably want to run them inside some type of container or virtual environment where you can easily restore back to a known good state. Okay, and we're just going to be using a simple agent that's using the React loop design. I've talked about this in some of my other videos, but basically the agent is going to reason, it's going to take certain actions, and it's going to kind of analyze that result, and it's going to kind of loop around in that React framework. React is just kind of one of the base designs for AI agents, and yeah, check out some other videos for more information about this. But yeah, this framework's very similar to other AI agent frameworks, other than this code execution feature, which makes it much more efficient. I guess another advantage to this is you have really good integrations into the Hugging Face ecosystem, and the Hugging Face ecosystem has so many different models available, and it's been constantly updated that, you know, if you really want to be on the bleeding edge, this would also be a good framework to invest time to learn. Okay, so we're going to run through some of these agents here. For example, here's just a simple agent where we are going to ask for what's the 111th number in the Fibonacci sequence. We can see that's going up to the Qwen 2.5 coder 32B instruct model on the Hugging Face API. And then we're getting back some code from that API call to the LLM, which will calculate the Fibonacci numbers. And we see there the final answer coming back after our agent executes that Python code. Now, there's a lot of base tools built into this. There's typically 3 tools enabled by default. One is a search tool by the DuckDuckGo search engine. One is the Python code interpreter to use the code agents features. And another is a transcriber, a speech-to-text pipeline built on Whisper technologies. I've used the DuckDuckGo web search agent tool, and that works really well. I've also used the Python code interpreter quite a bit, and that works well as well. I haven't tested the transcriber agent, so that's still on my to-do list. But I have not had any problems with these 3 default tools. Okay, we talked a little bit about Hugging Face, so I'm not going to talk about this to death, but just want to reiterate, it's kind of like the GitHub of the ML or AI world. You can create an account for free, and you get so many credits, and some types of GPUs that you can run your models on. If you want more power, that you can pay to upgrade to a pro account, and I think there's also some usage-based billing built into the system. But generally speaking, you can do a lot within the free tier. So I'd recommend you just go around and play with it one night if you haven't to date. Especially the spaces. The spaces are really fun. There's a lot of innovation in there, a lot of cool ideas, and would encourage you to just check them out. Okay, so let's get to the practical hands-on portion. Here, we're going to leverage a really simple agent just to solve a CTF. In a follow-on video, we'll talk more about a slightly more complex agent, which we'll actually use to find bugs in software code, like web applications, and automatically write proof-of-concept exploits. But for this video, I just want to keep you focused on the easy stuff first. All right, so flipping over to Cursor, my favorite IDE for today. We're going to be looking at a couple different models here. So first, we're going to be looking at that Qwen 2.5 coder 32B instruct model. This is totally usable within the free tier of Hugging Face. Then next, we're going to be looking at the Llama 3.3 70B instruct model. I needed to upgrade to a pro account to use this model, so I did so. And then the Hugging Face Pro DeepSeek model here on this DeepSeek Arc1 distilled Qwen 32B. We'll look at a little bit later as we start to add tools and things start to get more complex. And I've gotten a little bit better results, and we'll kind of see that as we go. All right, so for the first example that you can do with the free tier, here's the CTF challenge. Took this from a real world CTF challenge. Essentially, the name of the CTF challenge was Rotten64, and then the value was kind of this string with the double equals at the end. Makes us think, okay, this is probably base64 encoded, and we need to somehow decode this to get the flag. So just first off, in scenarios where I'm trying to develop an agent, I just like to know what known good inputs and known good outputs are going to look like, and then I can kind of build the middle to get me there. And that way, you can kind of keep your sanity while you're building the agents, especially if they start to go in weird directions. So first step is I kind of wanted to just solve this CTF challenge for myself so that I knew what a known good output should look like. So I went over to my favorite tool for these type of challenges, which is Cyberchef. So Cyberchef's a free tool where you can place an input. So here you see I've placed the string, and then you can drag and drop transforms over here, and then it's going to go ahead and transfer it and show you the output. So the first thing is do the double equal sign. I assumed it's a base64 encoded string, so I do the from base64 decoding recipe, and I see I don't really get the flag as the output. So then I went back and looked at the CTF challenge a little bit closer, and you can see it says 64 here, so that's probably referencing the base64, but then it says rotten in front of it. And the only thing I could really think about in this context was that there is a cipher called a rot13. And there's also, some other rot versions, but rot13 is the most common. And so I decided to try the same recipe again, but this time I would put the rot13 translation first, which will rotate the characters, and then I'll do the base64 decoding, and then we will get the flag. The flags start with the word flag, and then they have these curly braces, and then this is what you would copy and paste into the CTF portal to get some points. So that's, we know what good looks like now. So we can say, if the output doesn't have the first 4 letters of flag, then we know the AI model has failed. So go back and try again. That seems like a reasonable assumption, even for someone who hasn't solved this before. Okay, so let's just walk through this. I'm importing config parser, and from there, I'm just pulling the model name and the token from the app.ini file. That's kind of like a .env file equivalent. And then here, I'm just using the Hugging Face free models. And then I'm, from the SMOLAgents, pip module, I'm importing code agent and the Hugging Face APIs, and then I'm instantiating the Hugging Face APIs with the Hugging Face token. And then I am establishing a code agent. I don't have any tools associated with it, and other than the base tools which are added as true. And then we're just going to run it with the prompt of, will you decode this message, rot64, blah, blah, blah. We probably could have given it a little more context on this is from like a cybersecurity CTF and things like that. And that probably would have been helpful. But, you know, this should be good enough just to kind of show us getting off the ground. One thing is, the way that I generally work is I use this extension in the ecosystem. It's called dev containers. And once you install that, you'll need Docker installed, which I have installed in the system. And what that will do is I will use it to create a Ubuntu 2204 LTS Docker container. And, you know, you can see we're inside that container now because we're in /workspaces and then the name of the CTF solver directory. And so if you set up something similar to that, you can use my setup.sh files, or if you're on a Ubuntu 22.04 system, you can use this to set up all the requirements you need from scratch for any of the labs. I'll try to do another video going over how to set that up more. If you guys want me to, just leave a comment down below and then create the video. Okay, so here we go. This is the first one. We're gonna go and run it. We sent the prompt off to Hugging Face's APIs with this Qwen 2.5 coder, and we are letting it do its thing. So every time you run this, it's probably going to take slightly different paths. AI agents, you know, they kind of have a mind of their own. But essentially, it's going to go ahead. It decided that it was going to use the web search tool. Remembering, we passed in the default tools, which means it has web search, it has code evaluation, and it has that Whisper technology. So it's trying to find a website to base64 decode this and get back the output. You know, really, that's probably not the best choice, right? I mean, it can run native Python code. So after it realizes that's not working out, then it sends us back some native Python code to go ahead and decode it. But unfortunately, the decode fails, right? Because they need to do the rot13 before they do the base64 decoding. And here we can see, you know, it's determined the final answer is this, even though it doesn't have the word flag in it. Now, you know, this might do a little bit better job if we give it a slightly better prompt. We could go ahead and try that. Let's see, here's a slightly better prompt in this future lab. I'm gonna go ahead and copy it into this one and see if we do any better. All right, so this prompt now says, will you figure out how to decode this message between rot and 64 tags? The final answer will start with the word flag. And then we can say, this is from a cybersecurity CTF competition. All right, let's see how it's gonna go. I haven't tested this before, but I did just save the code. And so maybe we'll get better luck now that we've made the prompt a little better. All right, give it some time to think about this, see if it can figure it out this time. All right, so it went straight to the base64 code evaluation, so that's a better choice than last time. One thing that it's running into right here is it's saying, hey, you didn't give me the authority to import in the base64 library, and so I can't do that import. So this is one of the protections that's built into the framework. Essentially, if we have to whitelist all the pip modules that we want the AI agent to be able to load up when it gets code back from the LLM. So, you know, things we might want to not allow include like the OS pip module, right? So if it can import OS, then it can write files, it can delete files, and it can, you know, cause a lot of issues on the file system. So, you know, if you're going to give it permissions to do the OS or like a write or read file type operation, you know, you definitely want to have it inside some type of sandboxed or containerized environment, as, you know, things could go sideways pretty quick. Okay, nevertheless, I found a workaround around that. Instead of importing the base64 module, it just wrote its own base64 decoding algorithm. And then from there, it says the final answer is flag, but that's clearly not the right flag. So a little bit closer, but, you know, still no cigar. All right, so we're gonna try this again, but this time we're gonna upgrade the model to a slightly better model. So we're gonna use this llama model. You can see we're moving from 32 billion parameters to a 70 billion parameter model. So this is much bigger and theoretically much smarter. Let's give this guy a go and see how the bigger model does with essentially the same, you know, kind of not great prompt, like, will you decode this? All right, so it doesn't have authorization to import anything, and that definitely seems to be slowing it down. So we'll look in the next code base how we can give it authorization to code to import some things that are useful. It's trying to use a website to do the base64 decoding. You know, that can be a little bit tricky for the AI agent to figure out and slightly less reliable. So it looks like that failed too now. And we'll give it a little minute or two to kind of work on this. Okay, so in the next step, we'll come back to that when it finishes, but in the next step, the one addition we're going to make is we're going to give it these additional authorized imports for the base64 evaluated code. So we're going to say, hey, you can import base64, you can import bin ASCII, you can import codecs, just to try to help it so we can do the base64 decoding without having to reach out to websites or write its own base64 decoder, which is probably going to be less reliable. So once this fails out, or we can Control-C it, we'll go ahead and try this next one with the authorized imports. All right, so I just Control-C it because I don't want to wait for it to finish. All right, now let's try the next one. So we're using the slightly better model, and we're authorizing those 3 imports. And let's see if it's able to get this one solved up here. Tried to decode it, that failed. It is able to import the base64 module now, so that's good. One thing that you want to be cautious about is, every time we make a query to the LLM, that charges us a little bit of money. So we don't want to just let these AI agents run forever in case they go down the wrong path, or just in case they're not able to solve the problem. So the way that you can easily prevent that is by implementing a max steps variable. So you could basically say, if you don't solve this in 10 steps, then just give up and return whatever you got back to me. So that's what that next example is showing there. In this next example, we are going to use a slightly better model. We're going to use the Hugging Face Pro DeepSeek model. We're also just going to give it a few more hints about how to do this. We're just going to say, hey, you need to perform ROT13 and you need to do base64 decode. I did this because I was getting a little frustrated that the agent really wasn't able to figure it out on its own. So this is a general methodology I use. I start with a model that's pretty bare bones. If it can't do what I need, then I go to a better model. If it can't do what I need, I go to an even better model. And that seems to work well for me. You could also take the reverse approach where you start with the best model possible and then move down to cheaper models as you need to, streamline your operations in a cost-effective manner. So, either of those approaches work, but, generally I like to do cheapest to most expensive just so that, I'm not wasting money as I go. Okay, so let's try this with a slightly better prompt and using the DeepSeek R1 model. Now, the DeepSeek R1 model has that ability to do thinking, right? So, or it's referred to as a reasoning model. So it's going to be slower, right? But the core principle here is that it should be better at giving us, it should be smarter at getting us better responses. Based on the benchmarks, reasoning or thinking models, they generally are crushing it. They're kind of the new hotness. And, personally, even when I'm in Cursor, as you see here, I'm using the Claude Sonnet 3.7 thinking model for most of my work now, as I find that does the best with coding problems. So we will give this some time to kind of think. One thing that you may want to consider, in addition to max steps, is highlighted in this next sample. And that's where we're essentially going to add a timeout associated with it. So the default timeout is set to 120 for the Hugging Face API calls. And based on my testing with the DeepSeek R1 model, it felt like the model is taking longer than 120 seconds to think per API call. So I raised that limit up here in this last one to 300, and that got rid of some issues that I was running into. So, if you're trying to work along and, you're running into timing issues on the, sample 5, that's why I've added this increased time length here on sample 6 to resolve that. All right, I will speed up the video and the final one, but I'm going to go ahead and, run the final sample here, time's sake. Okay, we can see here that the AI agent was able to find the flag. We can scroll up to kind of see the steps it went through. So first, we kind of walked it through with the prompt what it needs to do. And then it created this code, which first used ROT13 on it to decode the cipher, and then used base64 to get the message. And there we go. It gave us the final one. Now, I've written a slightly improved prompt here. We did that all using the DeepSeek R1 distilled Qwen32B model on the Hugging Face ecosystem.